95 million years ago, a group of small ornithopods are drinking some water. But suddenly a predator arrives, Australovenator, the apex predator of this place. But what really did happen here during the late Cretaceous? Lark quarry is currently the only site which shows direct evidence of a large dinosaur stampede. The site was first discovered in the 1960s but wasn't excavated until the late 1970s. It's been heavily debated over what really happened here. Some scientists say the larger footprints belong to Australovenator, meanwhile others say it belongs to a plant-eating dino similar to Metabarosaurus. Paleontologist Anthony Romelio has been pushing the idea that this site wasn't caused by a stampede. Current paleontological studies show that this place wasn't the result of such stampede. But how do we know this? Can we assume we are always right? A study from 2014 put the footprints in 3D. The results showed the much clearer picture of it. This study concluded that unlike in the 1984 description, the tracks were most likely made by an iguanodontid dinosaur, possibly Metabarosaurus. The study also concluded that several of the track morphologies obtained from new 3D evaluation models differ considerably from the track outlines that were published in the original description of the site. Compared with the new set of representations, some of the original outlines seem to represent simpler, stylized versions of the tracks. A number of the original outlines are greater than 20% larger than the new models of these tracks, while others appear to incorporate cracks as part of the margin of digit impressions. Overall, the best preserved tracks show blunt digit impressions, reaffirming the idea that the track maker was a large ornithopod and supporting a reassignment to cf. Iguanodontopus. The new analysis also reveals the nature of the displacement rims associated with the tracks, and the overprinting of these rims by other arachnids, initially by tool marks presumably caused by floating vegetation, and then by other dinosaurian tracks, assignable to Wintonopus litomorum. In the context of these observations, the scientists see no evidence for an interaction between the cf. Iguanodontopus track maker and the smaller-bodied W. litomorum track makers, as neither can be inferred to have been present at the track site at, or even close to the same time. Despite this, some people don't agree. Matt A. White recreated a realistic Australovenator foot to test out this theory. The foot was reconstructed using 3D software on a computer, and then the computer model was used to create a synthetic replica, with a skin texture based on impressions known from other carnivorous dinosaurs. Using a sediment mix that they deemed to be similar to the original mud, the Lark quarry tracks were pressed into. White and his coworkers created tracks with their reconstructed Australovenator foot, including full foot impressions as well as heel slides, scale imprints and claw drag marks. The paper concluded that their makeshift footprints look more like the ones in Lark quarry than any iguanodontid footprints. White agrees that reconstructing a Metabarosaurus foot would be an interesting next step in this research, but says that this is not yet possible, as no complete fossil foot for the species exists. So, right now we don't really know what happened. It could be the one or the other, maybe even a mix of both, or something completely different.
In just the last few years, we have uncovered the most extraordinary fossils, exquisitely preserved and tantalizingly intact. Combined with the latest imaging technology, we have been able to probe deeper and reveal more than ever before. It gives us our first truly global view of these incredible animals.